This is the stage of our journey where we're building out our electric propulsion prototype. And you may be thinking, Ian, this looks like a flying saucer. Well, it kind of is, but the geometry has to be really precise. How it works is a matter of three factors: asymmetric capacitors with pulsed high voltage, counter-rotating magnets, and piezo crystal power cells. So asymmetric capacitors with pulsed high voltage, that creates a lift force. The counter-rotating magnets also create a propulsion, and the piezo power cells are what gives it energy. So you might give it some external energy because it might need 10 to 30,000 volts, and then the piezo power cells maintain that energy. And all it is a vibrating crystal. All right, so here is the printer we will be using. How this works is it takes filament, which is basically plastic. You put it on the spool holder. You can put it through here. This is called a filament runout sensor. So you put it through there, and when the filament runs out, it stops the print, so it gives you time to change it. This is an interesting printer because it has two extruders. So most printers just have one extruder, and this is what an extruder is. All it is you put the plastic end. This bit broke off in the car, but it's fine. We'll have to heat it up to remove it. And then you put it in there where this one is, and what happens is this extruder runs through the print and prints line by line all the way up until it's a full 3D part. And the cool thing about this one is this one has two extruders. Normally when you print something, you have to be really precise about how you angle the geometry so you don't have to have a lot of support. And some of our geometry is very complex, like rodent coils. So that's why we got a two extruder, because we have something called PVA filament. This is PVA filament. You want to keep this in the bag until you're ready to use it because it deteriorates.
Okay.
All right, so this is called PVA filament. So what you do is you put this filament in the second extruder, and in the software you say the second extruder is my support material. And what happens is you can print out a whole design, and the support will be in PVA. And the cool thing about PVA is after the design is done, you put it in warm water, it melts away the PVA, and then you have a final product. So that's only for the really complex geometry. Though in the software, you're gonna have to change this, it's really easy. But in the software, the extruders are set to 0.4 millimeters. But for our metal filament, we had to upgrade the nozzles to 0.6 millimeters for the left one, and the right one is 0.8 millimeters. So make sure that's 0.6 millimeters on the left and 0.8 on the right. 0.6, this is left. 0.6 millimeter, and right has a 0.8 millimeter.
And this is right now?
This is, I already installed them. So this just means that it has a slightly bigger nozzle on it because the metal filament is a little bit thicker. But you can practice, we'll leave it on because you can practice, what we're gonna do is you're gonna practice with the plastic because it's much cheaper. These are like 20 bucks a roll. Mm-hmm. The metal filament's like a couple $100 a roll. So use one for, let's say white is aluminum, copper's copper, gold is zirconium, and feel free to just print it all out in one color right now. If it's too complicated, it's not a big deal. Because it's just in plastic right now. But when we do go to metal, you'll have to be precise on which one goes on which.
For the material.
Yes, so currently there's 205 individual pieces of our current design. 205. But a lot of these pieces are really small. So like a lot of these pieces might be like this size. So you can load up all the small pieces in one print together. So that 205 pieces ends up being like 10 to 15 prints, each one about 8 hours long. So you could print 2 a day and be done in a week. Basically, that's our goal, of print out a full prototype in a week. So if you, so let's say one of the big things, right? That we have a dome. So this one might take 8 hours, right? If it's really big, right? First thing you want to do today is watch the setup tutorial that I already gave you for this printer, because you're gonna have to re-level it because it's been in the car, it's been shaking around. So you have to re-level it, make sure everything's level. And I want you to do 2 things today. I want you to print out the calibration cube. Remember, make sure in the software, you're gonna have to download this on your computer, it's free. You download Cura, and then you have to download the Sovol 4 extruders, and then you have to import them into Cura. It's a little complicated. If you have questions, let me know. It took me like 20 minutes to figure out. So then in Cura, you want to put a calibration cube for the left one, And a calibration cube is just a little cube it prints out to make sure the printer is level and everything's right. Obviously, you have to level the printer first. So level printer, watch the tutorial, it's easy. Calibrate, software, and then print calibration cube.
And that's kind of like the reference you brought me.
Print, yes, dual. This is all in the video I sent you of that little Asian girl making it. You can do all that. Just copy her.
Just copy her.
And she tells you about the software too. So like watch that video multiple times if you need to. Print dual, calibration, print. Okay, so let me walk you through this real quick. So first thing you want to do is watch the tutorial on this again to level the printer. Then you want to calibrate the software on your computer. You want to make sure it's loaded in properly. There's a USB slot right here. So like, let's say you want this printed this way. You do that all in the software, figure out what will be the fastest, what will make the most sense, what will need the least support. And then you do that in the software, you put it on the SD card, and then you print it.